builds off of the presentation Smeet gave a little while back about kind of what we wanted to do with the T7 AI moving forward, the new kind of design changes as well as architecture changes. I'm going to present a update to that and show where we are and what we're going to do moving forward, the short-term goals as well as some long-term goals. So just going to quickly go over the development plan that we set out previously, what we're currently developing, also some tools we're supporting, since this is very data-driven now, and then some roadmap stuff. So if it's the first time seeing it, we're going to implement behavior trees, animation state machine, Blackboard for data sharing. We're also going to decouple how animations come into the system compared to the current GSE code that they use. And we're going to remove code AI states completely. So GSE can actually run its own AI compared to code running Atom scripts. So some of the stuff we've done very recently, we've made this all GPT driven. You can select which behavior tree, which ASM you want to run, which animations you want to select from, aliases, push that into the linker as well. So this is all from data down, BAS files. It's very fast. We do all of our searching for animations. It's similar to a database style, all in code now, compared to script. So what we're doing now, as we continue, what we've been also doing before is converting from the Atom scripts into this new system. Right now, we're building out locomotion, as well as all the different covers that AI used to be able to support. And recently, we added the concept of layered animation handling. So AIs have different sorts of things like a base pose, aim additives in terms of humans, as well as shoots. These kind of build on top of each other. They're not required, but as we have new AI archetypes or new AIs, they can kind of just layer these things when it's necessary or when they want to use that. They're both independent, decoupled from each other. Also, so we're building out tools at the same time. The behavior trees can get pretty large in terms of the data, as well as the ASM. They're a JSON format. We have our own kind of primary core libraries, unit tested. Our editors are built with Qt, similar to what Radiant has now, so they can actually be used within Radiant, kind of going down the line. We share that across different editors as well. It's all data-driven, so we can actually change the behavior of the tools to support new features without recompiling the tools. This is kind of the paradigm we're going down. We want to do this with the linker as well, so that I can share data between the tools, the linker, and the game executable without ever having to introduce like kind of weird compiled dependency. So what we have for our behavior tree editor, the stuff on the left is the node support. This is all the data-driven stuff. The tool doesn't really know anything about what it's doing. It's just kind of a tree parser editor. The attributes on the right-hand side go along with each node type. These are all defined in data, so the tool can change rapidly. Smeet does it all the time when he needs new features. He just adds it in, no executable compile, and we can just read new formats essentially. So this is what we have right now. The top portion is kind of the cover selection behaviors. Then we have expose, and down we have locomotion as well. So you can see some like stand behavior, melee, grenade, reload, shooting. These all combine with an ASM, so you can see on the right-hand side ASM state that's associated, as well as a script function that I'll go into. So each of these small little stub script functions only know about themselves and how they're acting upon the AI agents, compared to previous Atom scripts that have to know about every single state that the AI could possibly go in, do a bunch of switch statements, things like that. It makes it a lot more reusable. We can switch it around, delete these nodes, reprioritize them really easily, and it's just data. For the ASMs, look, our tool looks like as well. We map to which specific tables. So in this case, this is an actual fleshed out representation of our current AI. We have cover states like shoot. Shoot can compose of any kind of the cover nodes that we support currently. We actually push that over to animation compared to code. Then we have exposed, locomotion, death, ragdoll, all that good stuff. So kind of the progress as we're going along. We fully fleshed out exposed behaviors that the AI currently supports in T6. With this new system, we're actually integrating the Havok navigation as well as Havok steering. So we can do smooth curves, things that the AI previously couldn't do. We're fleshing out all the cover nodes, 20 or so different cover node types, and then bringing back all the tools that we previously had, like some of the Rex AI tools, to support this new system. kind of look in-game. We threw some stuff up. This is how the behavior tree evaluates which current nodes in the tree is running, as well as which ASM state is currently in. So this is just reload. It kind of progressed through what's considered like a high-level soldier, and then it kind of drilled down, it determined that exposed was the best, then it attacked. It tried to attack, but it needs to do reload because that has no ammo, essentially. So when it's actually using locomotion, we can do path planning, essentially. We have curved paths now compared to the previous path nodes, which were kind of erratic. We can get these very smooth, almost Bezier curves. And in that sense, we can actually separate animation so that we can have these perfect curved animations playing that match the path almost exactly, and have it can actually pick up the steering. So animators can animate independently of AI engineers, and they can't essentially break the game. Because if their animation doesn't match up, we still move the AI along the path regardless. This is kind of how it's overlaid on the nav mesh now. That's all fully integrated. Cover is very similar. It's a little more complex just because there's so many different types of covers. But essentially it boils down to tree and behavior, and at the end of the day, this one's doing shoot enemy. And it can support all the normal shoot leans, shoot overs, blind fires, peeks, things like that. And at the end of the day, the AI, when it makes a decision, it only cares that it's shooting, not necessarily which animation or how it's shooting. So kind of in the short term, as we come up next couple of weeks, we want to get this all integrated together in terms of movement, expose, cover, and kind of supporting the basic AI, as well as starting to implement traversals. So this uses a new Havok technology as well, Havok user edges, and we'll start converting that. And as always, we're doing performance improvements kind of all the time, seeing where you can push stuff into code, so it's usable, or speed-wise, try to get it up to parity with the current system has for G6. So that's pretty much it. It's kind of just a short update. Any questions, concerns, comments?
I have a question.
Yeah.
Was that a call stack
Sort
that
of.
we were looking at for the decision tree?
Yeah, since it's a tree structure, it kind of recursively calls into its children nodes to see which ones are running. So we can see, to shorten it, once we've found a node that we need to execute on over multiple frames, it only has to check with its like lineage, essentially, instead of trying to research the entire tree. It only does a search if something completes and evaluates, and it needs to research to find another action to execute. Anything else?
Any idea when you're going to be able to integrate it into the main line?
It's more Samit's decision.
I don't know, like, I mean, we are thinking about basically getting more engineers to help us out in some of the tool tasks. Something that David was mentioning is we're trying to do the tools at the same time because they are helping us to speed up the implementation and get to the parity level at the D6. So that's where a lot of other engineers are going to help us. So we're hoping to get those engineers on our our work sooner than later. So considering that we want like a limited access in T7 branch, but for that we are basically hoping that we'll get the basic combat running so that if somebody like from the design team wants to experiment, they can come and do that too. So we're looking at about like mid, 1st July is our kind of like deadline to get this working. But then at that point we'll do a reevaluation of like, is it good enough to put back into the main branch? But if not, like by August 1st, we'll have everything running for sure, and we'll be back into the main line for everybody.
And we've started to bring in other artists, animators, things like that, as we get them used to the system and some of the tools that they use. Cool. Yes, kind of a short update. Okay, that's it.
It sounds like heads exploding all over the